Welcome back, Physical Science 20. This is the third video dealing with 1.3. But of course, he had the simulating video right before this. So technically, this could be the fourth video, but I'll refer to it as the third one. So we looked at interference patterns with one-dimensional waves, such as in a slinky or a rope, crest meeting crest, or trough meeting trough, and crest meeting trough, fairly easy to see. The water waves is a little more abstract. So that's why I use the simulator there to kind of show interference patterns that can result, what to look for, etc. Here's another example here. It's kind of more of a three-dimensional wave because we're looking at sound, which extends out in every direction. A clear example is the following. If you are standing around a corner on the side of a building, you cannot be hit by a baseball thrown from the other side, but you can definitely hear people shouting. So you know that you can hear sound around corners. So that indicates that sound bends around corners as well, or through little slits, indicating that diffraction does happen. So for example here, this is just a picture of a stage. Someone singing here, sound waves coming out, and if you happen to have one of the worst seats in the house in which you're standing behind a pole, of course you can still hear it. Or if you're in another room that has a window, etc., that's open, you of course can hear. But as we'll see, when I have two waves though, like when I have two sources there are times in which you will have cancellation, just like we've talked about before. And of course the circumstances would have to be such that there is no reflecting, because the problem with trying to see this in a room is that of course there's also wave reflection too, which we talk about in the next unit. Waves hitting off a wall, and then so you're exposed to many different waves if there is reflection, etc. But if there was no reflection, there would be areas of cancellation, of sound cancellation. All right, let's look a little bit at what we talked about in the simulation. So diffraction due to double slit opening, so we just looked at that. This is equivalent to the interference pattern produced when two rocks were thrown in. So yes, the resulting pattern is almost as if I just simply were making a point source at these two locations. So the straight waves come up, waves pass through the slit, and yes, bending around the corner. If this wavelength here, so this distance here, is equal to or larger to than the slit width. So we see here the slit width is really small. It's a little bit less than the wavelength, so we do get quite a bit of diffraction around there. So of course the same effect can be seen if straight waves pass through the single slit and then a double slit, such as here. Now what I did here, we're going to draw a couple of things on this diagram because I have one of these in the assignment as well. So looking at the interference pattern. So what I have here is that I have solid and dotted lines. It's kind of difficult to look at, but a solid line is a crest, dotted line is a trough. So rather than not showing the troughs, I showed them in this diagram because it's easier to draw the diagram or draw the nodal lines. So crest, trough, all the way. So interestingly enough here, if I have straight waves coming through a slit, it diffracts around. Because look at here, so from crest to crest is this distance, and you can see this distance is larger than this distance, so we get a lot of diffraction. And look, notice here, circular waves going through these slits also produce two circular waves. Okay. Now, what I want to do here, I want to draw what the nodal lines would look like on this diagram. So where I have these two interfering with each other, and the nodal lines, nodes, so points, and resulting nodal lines occur where crests meet troughs. All right, so I'm going to use a pencil here just to make sure if I do make a slight error, I can erase it. So as we saw it with the diagrams, the nodal lines kind of extend outwards like this, so we'll have to figure out exactly how that works. It's easy to see where crest meets crest and where trough meets trough. So right here you can see trough meets trough, crest meets crest, etc. But what I want to look for is where the crest meets a trough, where a solid and a dotted intersect. So if I look over here, right here for example, solid meets a dotted. So I'm going to make a little dot right there. Also over here, solid meets dotted. So this solid line meets the dotted line of the other one. So the crests here of this wave meeting the dotted lines of the other one, or vice versa. See, now I have the trough of this source meeting the crest of the other one. So what you should see is that these form lines. So we can see we get a bunch of points right there where a solid meets a dotted line. And then what I could do is just join that up. So those nodal points where a crest meets a trough. Of course, back in one-dimensional waves, we know what happens there, right? When a crest meets a trough, they cancel right when they meet. Cancel right where they meet. So we have that happening there. Now if I what I'm going to do is kind of look in this pattern where the pencil is. Kind of go like this and look for the lines, because my pencil will kind of show what those cancellation lines look like. What we saw in the simulation. So if I continue to kind of curve this way like the pencil, trough, trough, crest, crest, trough. So here I have constructive interference. So you can see the kind of like a diamond pattern here. And then continue moving. Oh, crest meets a trough. Crest meets a trough. Solid meets a dotted. So kind of going back this way, kind of making that curve that you saw there. See how that works there? Those dots there, crest meets trough. And the pattern looks like this, following my pencil. The lines will look like this, kind of jutting outwards from the center of this area here. So I could join up those nodal points, those nodes, and resulting nodal line occurs. Then keep curving out this way. You can see trough meeting trough, crest meeting crest, etc. But so keep going. Oh, here we go. Solid meets dotted, solid meets dotted, etc., etc., etc. So you can draw those nodes right there, and that results in the nodal line as well. All right, keep going here. So again, following this pattern. Going like that, making your eye follow that. So over here, another node. Over here, of course, we see crest meeting crest, trough meeting trough. So that means keep going here. Oh, right here we go. So a solid and a dotted. So you should get these lines forming here, because there's many solid meets dotted here, but you have to get the right pattern. Solid and dotted. There we go. So there's a line right there, jutting outwards. Keep moving, crest, crest, trough, trough, so keep moving, crest, trough, solid and dotted. So there's definitely a line right there. Keep moving, crest and crest. Oh, here's crest, trough, crest, trough, crest, trough, solid and dotted. So we'll have a line there. Keep going here, solid and a dotted line. And just kind of look for the pattern here. It should form a line coming outwards from the center area here. And I think we can likely squeeze one more partial one in here. So crest and crest. It's easy to see the crest and crest, isn't it? So just keep going. Solid, dotted, solid, dotted. I think we have another line right there. Whoops. So 1, 2, 3, 4, 5, 6, 7, 8. Should get 8 lines there. So you can see that coincides with what we saw in that interference demo that we did. Okay. So again, we're looking for nodes. Nodes, of course, occur when a crest meets a trough. And if I join up those points, we get these nodal lines. Areas where cancellation occur. And of course, in between here, crest and crest, trough and trough, we have antinodes. So let's say, so nodal lines. So if you drew this, just simply do this. Say, oh, here we go. And we can even further say that antinodes and nodal lines occur where constructive interference occurs. And we can just draw a few areas here, kind of in between. Then maybe up here we should likely mention destructive interference, because that's what's happening there. Where crest meets trough, points and lines, we have that happening. All right, what we'll do is we'll stop the video there. We'll have one more video just to finish off this unit, and then you'll be able to do the assignment.